Now let's move on to the next section, which is mint and NFT locally. Click on next. Here it is. Okay, okay, let's write our smart contract. Okay, go ahead and delete log.js under test, also redeploy.js, and let's delete these files as per instruction. Let's delete it. Let's delete it, and let's delete it. Okay, now we have deleted all. Now let's get a smart contract. With the name just copy it. Okay, okay, it's a bit uh, there's a bit explanation of the code. You can see my other series of Solidity smart contracts, where I have covered all the topics related to Solidity smart contracts creation, uh, from data type, functions, and everything. So you can check that out. Now let's move on and create a file named run.js under the scripts. Let's create a file and paste this code. Okay, now let's see how it works. This will actually compile our contract and generate the necessary files we need to work with our contract under the artifacts directory. Okay, so this line is going to compile our contract and create a files under the artifacts folder. We will see it after compiling it. Okay, now what's this line is? What's happening here is Hardhead will create a local Ethereum network for us, but just for this contract. Then after the script completes, it will destroy. So basically, Hardhead create a local blockchain network which will just run one time and just then destroy it. So every time you can run the contract, it will fresh blockchain. What's the point? It's like refreshing your local server every time, so you always start from a clean state, which make it easy to debug errors. Okay, then what this line is doing is uh, will wait until our contract is officially mined and deployed to our blockchain. That's great. Her actually creates fake miners on our machine to try its best to imitate to actual blockchain. Okay, that's line. I said that our if our contract is actually deployed or not. Okay, our constructor runs when we actually are fully deployed. Okay, we will get the contract address. Finally, once it's deployed, contract address will basically gives us the address of the deploy contract. The address is how we can actually find our contract on a blockchain. Blockchain local is our blockchain is local, which is us. So this isn't that cool. But there are a million contract on the actual blockchain. So this address gives us easy access to the contract we are interested in working with. This will come in handy when we deploy to actual blockchain in a few lessons. Okay, so basically, when we deploy a blockchain, our smart contract on a blockchain, it will give a unique address of that smart contract that we can use in our DApp. Now let's run it. Let's run it. Okay, this is my NFT contract deployed, and this is the address that we get. Okay, now one thing that they have mentioned is hard hat and HRE. These code blocks, you will constantly notice that we use HRE.ethers, but HRE is never imported anywhere. What type of sorcery is this? Directly from the hardcore docs themselves, you will notice this. The hard hat Ethereum environment, or HRE for short, is an object containing all the functionality the hard hat exposes when running a test or script. In reality, hard hat is the HRE. So what does this means? Well, every time you run a terminal command that starts with a npx hard hat, you are getting this HRE object built on the fly using the hardhat.config.js specified in your code. This means that you will never have to actually do some sort of import into your files like this one. So you will always get the HRE in your code when you just compile the code from this npx hardhat command. So that's it for this section. Now let's move on.